Okay, strange things are happening in our solar system, and we need to talk about them. Astronomers have discovered a series of icy rock fragments that appear to defy the laws of physics. These objects move through the solar system along strange paths that cannot be explained by the gravitational pull of our known planets. What if something is actually hiding out there? A ninth planet. There could be a massive icy world hidden in the outer reaches of our solar system, and astronomers are closer than ever to finding it. To uncover the truth, I called the lead researcher who is hunting for Planet 9. My name is Konstantin Batygin. I am a professor of planetary astrophysics at the California Institute of Technology, and I have been searching for Planet 9 for the past decade. The craziest part is that after that conversation, I began to believe that Planet 9 truly exists, and interestingly, I think we may find it sooner than you expect. Throughout history, we have developed new tools and methods to explore space. With each major breakthrough, we usually discovered a few new planets. Mercury, Venus, Mars, Jupiter, and Saturn are the 5 major planets that have been known for thousands of years. At first, they were thought to be nothing more than bright, wandering stars in the sky. In fact, the word planet comes from the Greek word meaning wanderer. Then, in 1781, the invention of the telescope marked another major milestone. William Herschel pointed his telescope toward the sky and noticed a faint star that moved between nights of observation. This object became a new planet called Uranus. Initially, however, the planet was named George after King George III. After that, the search for new planets slowed down. We found nothing. Some even believed that we had discovered all the planets in the solar system, but there was a problem. Uranus did not match its expected orbit. It deviated from its predicted path, and no one knew why. Scientists began to speculate about what could be causing this, and an exciting idea emerged. What if there was another massive planet, yet undiscovered, affecting Uranus's orbit? This was a major triumph in celestial mechanics in the mid-1800s. Urbain Leverrier demonstrated that the orbital deviations of Uranus could only be explained if an additional planet existed. The mathematician Leverrier calculated the size of such a planet and where it should be located. Telescopes were pointed toward the predicted position, and there it was, Neptune, found just 1 degree away from Leverrier's prediction. When the predicted planet was actually discovered, suddenly everyone wanted to do the same. By the early 1900s, the solar system appeared to be nearly complete. Then it turned out that Neptune's orbit also showed irregularities, leading astronomers to predict the existence of another planet even farther out. Using new telescopes, astronomers searched the outer regions of the solar system once again, and as a result, somewhat by chance, they discovered the young planet Pluto. Pluto was accepted as the 9th planet of the solar system, but this decision eventually became controversial. As the 2000s approached, large survey telescopes began discovering hundreds of new objects beyond Neptune. These objects ranged in size, with some even larger than Pluto. This icy region became known as the Kuiper Belt. In 2006, Pluto was reclassified as a dwarf planet. Our solar system was left with only 8 planets. That is where we stand today. However, there is something strange happening in the Kuiper Belt, signs that point to the existence of a 9th massive planet. Many studies have investigated this idea, but all of them initially produced incorrect conclusions. So now, let's try to find Planet 9. In 2014, while astronomers were studying objects in the Kuiper Belt, they noticed something intriguing. Distant objects appeared to be strangely clustered together. They all seemed to be moving in the same direction, as if something were pulling them. The probability of such an alignment occurring by chance is extremely low. They all moved in a spiral-like pattern, tilted at a specific angle. I thought to myself, this must be an orbital alignment. We were beginning to see the first signs of something strange. 2 years later, astronomers Konstantin Batygin and Mike Brown from Caltech took this idea and developed it further. They ran simulations to find something that could explain these strange orbits. What was the solution? A massive planet located very far away, on a tilted and eccentric orbit. This planet would cause objects to cluster on the opposite side of the Sun, forcing them to avoid the planet's S-path and allowing this alignment to persist for billions of years. Their simulations predicted a massive orbit approximately 400 miles wide. Far beyond the most distant places on Earth, the planet would take between 10,000 and 15,000 years to complete a single orbit. Around the Sun, its orbit would be highly inclined compared to the rest of the planets in the solar system. The planet's mass would be about 6 times that of Earth, making it a super-Earth or a mini-Neptune. It would likely be 2 to 3 times larger than Earth and probably a rocky, icy planet. Interestingly, as we learn more about exoplanets in the Milky Way, we find that planets of this size are among the most common in the universe. Yet no such planet exists in our solar system unless Planet 9 really is hiding. The evidence for Planet 9 is not limited to the clustered objects in the Kuiper Belt. There are other objects even farther out that move in truly bizarre ways. In the outer solar system, Neptune acts like a kind of bouncer. Small objects that come too close are scattered into the Kuiper Belt. There is a dwarf planet called Cygnus which has an extremely distant orbit. It never comes close enough to Neptune to be affected by its gravity, making it an independent object. But here is the problem. Without the gravitational influence of the giant planets, how did it get placed into such a distant orbit? This requires another explanation, and this is where Planet 9 comes in. Over millions of years, the hypothesized Planet 9 gently nudges these distant objects, pushing them even farther away from the gas giants and detaching them from Neptune's influence. This phenomenon is not limited to Sedna. There are 4 confirmed objects whose motions are perfectly explained by the existence of Planet 9. Planet 9's gravity not only clusters these objects, but also scatters them in unusual ways. There are many strange objects that orbit the Sun at extreme inclinations relative to the rest of the solar system, some even moving in the opposite direction. Before Planet 9 was proposed, there was no satisfying explanation for how these objects ended up in such orbits. When simulations are run, treating Planet 9 as a guide, over millions of years it gently shepherds these objects into extremely high orbits. These simulations made me deeply curious about how understanding Planet 9's location could help us understand how the entire solar system formed. Essentially, scientists create 2 simulations of the solar system, one with Planet 9 and one without it, and then let them run for billions of years to observe the differences. When Planet 9 is included, the small objects in the outer solar system no longer appear randomly distributed. As shown earlier, they organize themselves. These are the distinct fingerprints that Planet 9 leaves on the outer solar system. Constantine also told me about a new prediction produced by the simulations that is rarely discussed on YouTube. The latest evidence suggests that if Planet 9 exists, this process has not only been occurring over the past 4.5 billion years, but is still happening today. Between Jupiter and Neptune, there should be a region where outer solar system material becomes trapped in a constant flow. Objects that cross Neptune's orbit should also exist. If Planet 9 did not exist, we would expect Neptune to eject these objects from the solar system over time. But if Planet 9 exists, objects in this region are continuously pushed inward. Planet 9 and Neptune appear to be playing a kind of capture game with these icy objects. In simulations, Planet 9's gravity captures some objects from the Oort cloud and sends them inward beyond Neptune. Without Planet 9, almost no objects would behave this way. They would either remain near Neptune's orbit or be rapidly ejected. This presents a new testable prediction. If Planet 9 exists, about 3% of objects beyond Neptune should have orbits that intersect Neptune's path. If it does not exist, only about 0.5% would be expected to do so. Naturally, my next question was, have we found any of these objects? So far, about 29 have been identified. When comparing results from simulations with and without Planet 9, even after correcting for observational biases, the conclusion is clear. The real orbits of the 29 discovered objects match the Planet 9 simulations, and the solar system model without Planet 9 is rejected at the 5 sigma level. For those unfamiliar, 5 sigma is the gold standard in science. When a result reaches 5 sigma, the probability of it being a random fluctuation is about 1 in 3.5 million. This result almost entirely eliminates the possibility that Planet 9 does not exist. But wait, we only have 29 objects, and fewer than half of them have well-defined orbits. These objects are faint and extremely difficult to observe. But as you'll see next, this is about to change thanks to a very special telescope. Now I need to answer the question that many of you are probably asking while staring at the screen. If we know the orbit and size so well, why don't astronomers just point a telescope at the region of the sky where Planet 9 should be and take a picture? After all, that's what they did with Neptune. I get it. I had the same thought. The truth is, we don't actually know where to look. We can calculate the orbit, but we don't know where Planet 9 currently is along that orbit. That's because we haven't yet observed Kuiper Belt objects complete full orbits, so we know the orbit's shape. But Planet 9 could be anywhere along it. One orbit around the Sun takes between 10,000 and 15,000 years, so we need to precisely locate it to find it. There is also the challenge of distance. These objects are extremely far away, which makes them incredibly faint. This isn't a matter of simply pointing a telescope at the sky and watching the data come in. It pushes and possibly exceeds the limits of our largest existing telescopes. Finding Planet 9 requires a more serious effort. Our best telescopes push their limits by taking long exposures and stacking multiple images to reveal what's hidden in the darkness. Many such searches for Planet 9 have already been conducted. The Subaru telescope in Japan captured deep wide-field images in a 2020 study. It found more small, icy rocks that support Planet 9's existence, but not the planet itself. The Pan-STARRS telescope in Hawaii searched during the 2010s, but couldn't detect objects faint enough. The Dark Energy Survey covered 12% of the sky between 2013 and 2019, yet still found no Planet 9 candidate. What I'm trying to say is that until recently, our telescopes and data simply weren't good enough to properly search for Planet 9. This is where the Vera Rubin Observatory comes in. I actually visited the observatory in Chile a few months ago. Once it is fully completed, I made a comprehensive video covering its scientific details. If you haven't seen it yet, you should definitely check it out. Vera Rubin has an enormous 8.4-meter mirror and quite literally the largest camera ever built. It is a masterpiece of modern engineering, designed to carry out the largest sky survey in history. But what truly sets Rubin apart is its speed. It can capture massive images rapidly, scanning the entire visible sky every 3 nights to an unprecedented depth. What once took months or years for previous telescopes will now take days. It is so sensitive that it could detect a single candle burning on the surface of the moon. They will essentially create a 10-year time-lapse of the entire sky. Rubin will be able to definitively determine whether Planet 9 exists, and at 1 T-take long, we could know within the next year or two. Rubin will discover many more of the delicate objects we've discussed, and provide the data needed to refine the Planet 9 model. So if it exists, I believe we'll at least know statistically within 2 years. This telescope is truly a planet hunter's dream. It's like having the world's most precise security camera constantly scanning the sky in search of a hidden planet. Personally, I believe Rubin will find Planet 9. That's just my opinion. But let's say it doesn't. What other possibilities are there? The most common argument against Planet 9 has always been that it's simply an observational illusion. Maybe those orbital anomalies aren't real. Maybe we're biasing ourselves by looking at certain regions of the sky. Maybe those clustered objects are just a temporary snapshot of a random distribution. If that's the case, Rubin will fill in those gaps. Another possible explanation is that these strange orbits are the result of Neptune's outward migration in the past. 4 billion years ago, Neptune moved outward and may have captured some objects, creating the clustered structures we see today. Other ideas also exist in the literature. Some have suggested that Planet 9 could actually be a primordial black hole. It could have the same mass as the expected planet, but an event horizon only a few centimeters wide. Observing such an object directly from Earth would not be practical. This could explain why we haven't seen it yet, but it remains highly speculative. Having a black hole companion in our solar system would be extraordinary, but this idea exists only in theory. No primordial black hole has ever been observed. Some even suggest that such objects could be the source of dark matter. If we were to find something like this in our solar system, it would fundamentally change cosmology. Constantine and his collaborator Mike Brown previously stated that they estimated the probability of Planet 9's existence at around 90%. After researching this topic for months, I can say that there seem to be 2 main viewpoints among astronomers, those who support Planet 9 and those who believe it is merely an observational illusion. At the moment, the latter appears to be a much less likely possibility. If you follow the data, Planet 9 emerges as a natural conclusion. Regardless of which side you're on, Vera Rubin will reveal the truth, and soon. And if we do find Planet 9, when I found evidence suggesting it exists, my first question was, how did it get there? One leading theory suggests that Planet 9 was originally an ice giant like Neptune or Uranus that was ejected from the early solar system and sent flying into the cold outer regions. This would make Planet 9 the abandoned core of a failed ice giant, now wandering far from the rest of the planetary family. It didn't T-form out there. There simply wasn't enough material in the solar disk to reach 500 astronomical units. Such a disk would almost certainly be gravitationally unstable. If it wasn't ejected, the only other possibility is that Planet 9 was captured from another star that passed nearby. The Sun was born in a star cluster, and before the systems drifted apart, we may have exchanged planets. Of course, the final question we must ask is, if we find Planet 9, what should we name it? While planets are traditionally named after figures from Greek or Roman mythology, the final decision will be made by the IAU and the Discovery team.